Hello. This is a slight correction / addition to section 2.5. It came to my attention recently that I had slightly misspoke when talking about the algorithm to finding an LU factorization. So I do sincerely apologize for that. What had happened was I have a method of actually calculating an LU factorization for matrices, but I sort of think it's a little confusing. And so what I was trying to do was, in the lecture, I thought I had this sort of slightly easier way of sort of defining this LU, or sort of creating the algorithm to find an LU factorization. And it turns out in the process of doing that, I accidentally misspoke a little bit. So what I want to do is redo this same example from the section 2.5 number 2 video. And then I'm going to add on one more example at the end, just so I can talk about the correct way to do it. So what I do when finding a LU factorization, we still find U the exact same way. So the issue I had was with finding L, not U. So we're still going to find U by turning this into a R row echelon form matrix. But what we're going to do is, instead of performing these opposite row operations on the identity matrix, we're going to fill in this sort of blank L matrix with the entries necessary so that the exact operations we perform will always give me the identity matrix from L. So I'll show you what I mean. So the first step here to row reducing this matrix would be negative 3R1 plus R2. And so now this would get me to negative 4, 4, negative 2, 0, 3, negative 5, 3, negative 1, negative 4, 8, 0. So the opposite row operation to get from here to here would be, so the opposite row operation would be 3R1 plus R2. And so what I want to fill in here is a 3. Because notice, to transform this matrix into the identity, I would want to get rid of whatever these 3 entries are. And so notice this row operation will get rid of that 3. All right, so next up, I'd want to do 1/2 row 1 plus row 3. To get that. So now 1/2 R1 plus R3. Well, if I were to do that row operation on this matrix, I'd want a negative 1/2 there. And so finally, we could do 2R2 plus R3. And so I'd get that matrix. And so this is an REF matrix. I'd want to put a negative 2 here. And so notice what we're going for. We want this matrix, when I do these 3 row operations, to turn into the identity matrix. And so again, I'm not quite doing the opposite set of row operations, but I'm just filling these in so that these exact row operations would give me the identity matrix. I think actually another sort of interesting way of looking at it would be to look at the 3 elementary matrices that are sort of opposites to these. So take the elementary matrix right, so notice this is the elementary matrix that's opposite to the first row operation. This is the elementary matrix that's opposite to the second row operation. And this is the elementary matrix that's opposite to the third row operation. An alternative way would be to sort of just stack all of these on top of each other, and that would give you L. So it's actually kind of funny, like I said, going back watching through both of the videos of LU factorizations, I ended up finding the correct L's, I think, but just the way I described it was technically a little incorrect. So I think, either one of these two ways, the way I did it, where you sort of fill these in individually, or if you just sort of calculate the opposite elementary matrix to each individual row operation, and then just stack them on top of each other, that will get you L. So like I said, I want to do one more example just to give one more example of how this works. So let's do the matrix 4, 3, 5. Sorry, 4, 3, negative 5, negative 4, negative 5, 7, and 8, 6, negative 8. All right, so what we can do here, well, so again, we're going to start off with this matrix L. And leave the lower triangular entries blank. So first row step here would be row 1 plus row 2. And so here, notice I've got row 1 plus row 2, right? So the opposite elementary matrix would be negative row 1 plus row 2. And so I'd fill in a negative 1 there. Here, next, I'd have negative 2 row 1 plus row 3. So I'd fill in a 2 here because the opposite elementary matrix, again, would have me put a 2 right there. And again, by opposite elementary matrix, I mean the matrix that performing this row operation on E1, notice, would turn E1 into the identity. Alternatively, again, the operation, if I did this row operation on L, this would turn this entry into a 0. Notice that at this point, U is already in row echelon form. When this happens, and I still haven't filled in this entry, I just put a 0 there. And so this would be my LU factorization. Again, I apologize for the slight confusion. And so if you actually watch, like I said, if you watch the videos, despite what I say, I'm doing it correctly. So just try and ignore what I'm saying and watch what I'm doing. But this is the slightly more correct way, or the much more correct way, I guess, of technically finding an LU factorization.